How does an astronomer on a small, tiny island floating in the middle of nowhere look up and somehow figure out that millions and millions of light years away, a star happens to be burning helium or carbon? How can a small experiment that we can do right in our lab here at school help us answer these really deep questions? How is this related to neon signs? What is the physics that might be involved with both of these questions? The answer is emission lines, and this is one of my favorite parts of physics. If you like this section, by the way, you should talk to me. There's a whole bunch of jobs that relate to this. In order to introduce you to this, I'm going to take you into the lab room, and we're going to have a tube of gas there. We're all going to stand there as a class. And I'm going to have hydrogen trapped in there. What I'm basically going to do is I'm just going to send a little electrical current through here, sort of excite the hydrogen. Oh wow, did I just spell hydrogen wrong? That's not even close. Okay, I fixed it now. We're going to excite that hydrogen. What you're going to see is it's going to look kind of cute and pink. So then I'm going to give you these special little glasses. And what you're going to see is actually going to be really weird. You're going to see the glowing tube of hydrogen gas. Okay. And then kind of over to the side, you're going to see a very distinct, it's almost going to look like an echo of light. It's going to be the same tube, but you're going to see it in different colors. This is actually going to give us one of the best indications of what's going on inside of an atom. It's almost like you get to stretch apart space and time and look actually inside the atom. I'll explain why. Then I'm going to take some different gases and I'm going to excite them also. And you're going to see that each of them has a different color. And also when you put on the glasses, you're going to see other they're going to look like little color echoes that are going to be spread out. We call that an emission spectrum. Each of the different gases I'm going to put in there are going to actually look a little bit different. So here is the hydrogen that we looked at first, and then helium and neon and sodium and mercury. So they each have sort of like their own fingerprint that they put out. You can start to see why this might be useful in identifying what stars are burning. What exactly is happening here? Well, it all comes down to the way we think about the atom. This is a really outdated sort of idea of an atom, and we just covered that. These are not representative of where the little electron is going. These are more representative of the energy that an electron would have. Down here, we can almost think of it as sort of the ground floor, where the electron has the least energy. Out here, it'd have more and more and more, and actually there's more energy levels than these. I'm just using this as a basic idea. So what happens? Originally, let's say we had an electron hanging out at a lower energy level. And then I excite it through electricity, heat, something along those lines, and it jumps up to a higher energy level. When it falls back down, it's going to lose some of that energy. So it drops down because it lost the energy. As it does that, it's going to give that energy off as light. What color of light? Well, it depends on where we went from here. So whatever that change in energy was is equal to Planck's constant times the frequency. So different jumps, if you went from here all the way out here and then you came back down, you're going to have a different amount of energy than if you just went from here to here. Therefore, you're going to have different frequencies of light coming off. That's what those different colors correspond to that you're seeing for hydrogen.